We still made it again. Hashtag 7 o'clock people. I love it. On time crew. Welcome. It is at 7 p.m. I am here with my LaCroix Curate, the Cerise Limon today. Just getting set up. I switched up the whole thing again. Like I said, I was having some trouble with the VM yesterday, and I was like, you know what? We got to get back to our System 76 laptop just because it works a little bit smoother. Everything works a little bit better. And so we are using that today instead, but I forgot how many inputs I had changed when I got this mixer and everything else, and it was a mess. So there's a solid chance that maybe we only have this view right now. Maybe we might not have a computer. We definitely don't have an iPad today because of that. But what's up, Sandpaper? How you doing tonight? What's up, YGBSM? Always on time crew. Managed Chaos, you're welcome. Good to see you. What's up, Diarrhea? Every time, I can't even see. I honestly, because of the blue on this screen, I can't even really see your name, but I know the length of it, and I can always see the W at the end and the D at the front, and I know exactly who you are. So what's up? On time, every time. What's up, Greatest Rob? M. Gene, how's everyone doing tonight? All right, man, I did not get stuff shipped out yet. I'm gonna get stuff shipped out hopefully tomorrow. I just keep having super busy days at work. Like today we had like a whole like company meeting about things that are going on right now during like lunchtime, so I didn't get out and send some stuff off, but I did not forget about you or Aya, I promise you. What's up, Arman? What's up, Enigma? How's everyone doing? Delarus, Sharky, what's up, bro? Yeah, you've been holding out on us on the Warzone, man. We got a second placer last night. We did not do well at all last night. We had some terrible runs. What's up, Hugo? Hi from London. Hello from Baltimore. Skipped last stream because my car broke down. I'm sorry to hear that. Not to buy 2000 Mercedes learned. Hey, I mean, you know, it's mechanical things. They can always be, you know, fixed eventually. You know, I'm sorry that happened to you. It is super unfortunate. I hate, like, having car troubles is like the worst thing ever. It's so inconvenient. You can't just fix it, and you're at the whim of the dealer or the mechanic for how much it's gonna cost. That username is one for the agent. It really is, though. Sean, good to see you with the eyes. I see you still got the you still got the train emoji. I see. We're taking advantage of the double XP. Yeah, I mean, you know, it's been I'm not gonna lie, it's been a really, really good, just like, one, I get to, in a time that I don't get to hang out with my friends. So I used to go to this meetup every Thursday. We used to always hang out afterwards, go out to eat together and stuff. And like, these are my friends. And, you know, it's another way for us to kind of interact, have some fun, just blow off some steam for the day. You know, I definitely should have been doing some other things, but it's okay. Sometimes you got to do that. So I probably won't be playing at all tonight because I have a lot, but yeah. No one is taking my crowd yet. That's funny. That's pretty funny. Yeah, so tonight we are on to getting funky with functions, and it is going to be probably like, it's going to be the thing that's going to tie up the bow to the tools. Like, this is the last piece of tools. You've already interacted with this already, but you don't know it yet. And again, all you're gonna be doing, like, after you learn this last piece, the functions and scope actually is what we're gonna be doing tonight. You're gonna be learning a little more. Everything you're gonna be doing after this is like practicing getting comfortable with these tools, to be honest, to solve problems. How do you put all these many different tools together to get to an end goal that you want? Of course, there are other concepts to learn throughout your programming journey. And we'll still be covering some of those bigger concepts, but they're all going to be basically using the things that we've learned so far. What's up, Sayugi? Welcome to the channel. Thank you for the follow. Good to have you. I was going to black out Tuesday for today's class, but that's fair. So that's fair. I thought about it. The only reason I appreciate that. One of the only reasons why I'm keeping going as normal no matter what this time is due to some times tables of some things that I want to do after this. I have some really important stuff the week following this that I probably won't be able to stream if we have to extend it at all. But I appreciate that. I definitely appreciate that. You coming through. What's up, Jitter Ted? Welcome with the early raid party of 17. Just dropped in super duper early. I appreciate it. How you doing? I'll give you a shout out in a second. One second. I'm still getting set up over here. Let's do SO. How you doing today? I'm typing with one hand because my everything is I messed up my whole stuff. I appreciate it. Really do appreciate it. Today, like I said, we're going to be learning about functions and scope in programming, and I am almost ready. I'm super close to being ready. I'm using my System 76 laptop again now, but I need to figure out how to like get my chat here so I can my keyboard's over to the right, my laptop's here in the middle. So I'm just trying to figure that out, but I think I got it. And I got up all my metrics. I also have, even though we're not gonna have a whiteboard today because I had to change everything around, I also have my monitor that's monitoring what's going on right here in my face. So when I forget inevitably to change back to our main screen from our whiteboard screen, I will see it and I will be ready. But welcome, Raiders. How's everyone doing? Good to have you. Welcome to the channel. Come on in, get comfortable, relax on this nice, what is today? Tuesday? You know, the days are kind of going together, you know. It's crazy that everything is still going on. You know, people forget we're still under quarantine, most of us at least. Here in Baltimore, Maryland, actually, you can go out to eat for places that have an outside seating. So maybe we'll be, maybe we'll be getting into that. Maybe we'll find some restaurants or something this weekend. But yeah, the dreaded switch of computers for streaming. Yes, big mistake. I mean, not big mistake. I used to use this, but when I say I switched it up. Usually I go live at 6:50, and I go live for the starting soon stage for 10 minutes, but I didn't get started until like 6:53 because I started switching up the computers at like 6:49, which was a big mistake. But I think I'm okay. I just lost access again to the iPad, but that's not a big deal. So let's head over here just for the coming times. You know, just that was a little clip you saw my background. Just my little show of solidarity a little bit here. But tonight, let's hop over into the Google Classroom, and let's grab those slides and let's take a look at them and see what we're going to be getting into tonight. Now, the concepts of tonight are going to be relatively, I think they're relatively simple on the high level to kind of learn. And I think we'll be able to get hands-on, basically practicing most of the things that we've learned over the entire course so far. So I think that should be fun. I think we're gonna get to learn a lot. So tonight is functions and scope. Pack and reuse is that'll make more sense once we learn a little bit. We'll give people another 1 or 2 minutes to get in. I have no announcements really, except for that. Just get ready for the 100 days of code starting next week. Some information will be coming out about that. Hopefully, I'm trying to get everything together very soon. I did not forget. I just need everyone to bear with me. I did not forget about your the coding challenges and the assignments for this course. They are ready. They needed to be moved from like I did everything wrong. Trying to do these things, I did everything wrong. I'm trying to clean it up so that everyone's stuff is not all in disarray. So the work is done, but the underlying integrations between the Google Classroom and the GitHub Classroom have taken a little more than I wanted to. It was a little more complicated than I thought. It wasn't. I'm just stupid, to be honest. So I promise you'll get that. Just be patient with me. Code Show, appreciate the 30 bits. I love the Python emotes there. I like that. That's really good. That's some, you got, with the Rust in there. Perfect, because we're doing 100 days of code. I am doing Rust for the 100 days of code. Now, I'm probably not going to start Rust until day like 20. I'm actually going to spend the first 20 days, first 19 or 20 days, working on a project that I've been working on, and I'll share more about that as well. We'll be talking about this stuff a lot. We're gonna be very visible during this time of what we're working on and just what we're trying to learn. Then I'll be diving into Rust for 80 of those days. Hopefully 80 of those days, maybe faster if I get to if I get done with what I need to get done beforehand. So it's gonna be pretty dope. Rust seems distinguishedly low level. Yeah, I mean, disgustingly low level. Yeah, I mean, and that's what I like. As I went from like Python and like Bash and Ruby and stuff to Go, I knew Java a little bit before that. Like I learned so much because I had to learn so many more concepts about computing, period. And I'm hoping that the learning of Rust will help me out even more, will really give me some more insight into the things that I'm doing, help me solve problems a little better when I really understand what's happening at the lower level of things. Someone who's never done Rust before, hop in and easily learn things. I have no idea. I mean, if you know how to code already, maybe. I'm hoping I can just hop in and learn some things. I'm pretty confident that I'll be able to hop in and do some stuff. but if you're still trying to pick up a lot of the core concepts of computer science and coding and computer science, it's probably going to be tough. Probably learn Rust, to be honest. Right. Well, nothing's, well, I wouldn't say nothing, but yes, most things are not low level if you compare them to C. All right, let's do this tonight. Function and scope, pack and reuse. So what in the world is a function? So a function is simply a block of code which only runs when called. Well, that's not the definition of a function, but that is what a function, that's part of what a function is. Another piece of it is that you can pass data known as parameters into a function, and there's actually a whole slide on that a little bit later, and a function can return data as a result. So a function is a piece of code that that you can right now imagine as a little packaged up piece of code that you can use, but it doesn't run by default. The interpreter, when you write a function, if the interpreter runs or the compiler runs, it won't just run that bit of code. After you write this little packaged up piece of code, the way that you actually use it is you have to actually do something called, you have to call it. You have to invoke that function, and then it'll run. And because you've packaged up this little bit of code, you can run it over and over again. You can run it multiple times. You can use it many times throughout your program. And so we're going to contextualize that tonight. One of the big things that can pass in, you can pass data into functions, which is nice, and you can get data out. So functions, I don't know if you remember in the beginning when we talked about what programming really was, one of the things I said was that all programming really is you taking in information, processing it, modifying it, making some decisions, and then spitting information out. That's really all you're gonna be doing while you're programming, is constantly passing around information, taking it in, modifying it a bit, and passing new information out. And that is what these functions are going to easily allow us to do, and it's going to allow us to do it over and over again without having to rewrite code. And so you might be thinking, it sounds like a loop. Not quite, but you can use them in loops if you'd like. So how do we create a function? So this was written specifically for Python, and I took this right off of the slides from the Python course. But we're going to be talking about how you make functions and a lot of other things. Tonight, we're actually going to be writing a lot of Go, well, a lot of Python, a lot of Go tonight as well. We're going to probably do everything one-to-one for these concepts in particular. But it's also interesting because I think this concept in particular is one of the cleaner ones that maps between every language. Like, this is like, the way this kind of exists is really kind of standard kind of across the board. But in Python, we use the def keyword to define a function. So that's in Python only. And different languages use different keywords to define a function. So when I say a keyword to define the function, think back to when we did an if statement. And remember, to start an if statement, you type in if, and remember, it turns a different color, and that lets the compiler, that lets the interpreter know you are starting an if statement there. Def is the keyword to define a function in Python. I think it's also the keyword in like Ruby. Other languages like JavaScript, maybe we'll write some in JavaScript tonight as well. And JavaScript, I think it's function. The whole word function is the keyword to define a function. And Go, I think is just func. But yeah, there's just different words to define the function, and that's how you start it off. But when you see parentheses, think function. And I know you might be saying, hey, that's confusing to me, because I told you before to think of parentheses when we were learning, at least the Python portion. It was, whatever we learned, it was either think arrays or it was think tuple, when we were learning the Python stuff. Yes, that's true. And that's true when you're talking about a collection of data. But whenever you see a kind of a word with parentheses after it, with things inside of parentheses, you want to be thinking function. It's a signature of a function. So this is just an example. Def is how I say, hey, there's a function. I give the function a name, and then I put these two parentheses here that kind of help it run as a function. So we're gonna we're gonna run through every single slide, because there are only 8 of them, 7 of them. Because again, like I said, the topic is relatively simple to kind of at like high level understand, but I think you got to get hands on with it to really start to know, what to do with these things. So that's how you create a function with just these. Think about these parentheses. So the keyword. So maybe it's function, maybe it's def. Give it a name, and these open and close parentheses are going to be generally how you define that function. We'll see those done in a couple different languages here. And then I said, remember how in the beginning we said functions are only Functions only run once they're called. How do you call a function? So if you define a function, you set up your function using that def keyword or that function keyword. How do you call it? How do you invoke that function? How do you make sure it runs? And you do it by calling it, and that's Connor McGregor over to the right, and he's calling someone. I don't really know. I'm sure he just knocked someone out, or he just got into the ring and he's about to knock someone out or get knocked out. You know, fighters are kind of crazy. But yes, you just call it by name, of course. So you see that thing at the end, and the way that you call it is basically saying its name, and with the parentheses, the open and close parentheses, to let the compiler or the interpreter know that you're calling the function rather than trying to refer to a variable name. And actually we'll start looking at that first, and then we'll come back to function arguments really quick. And so let's get hands-on with some functions. We'll go down here, and I hadn't used this computer in a little while, but I have to say, what a breath of fresh air. So it doesn't have all my settings that I like, but it's okay. You can see how the prompt is a little bit different. We don't have that simple pure prompt that we're used to. And we also don't have the stuff available to us that we normally have. But let's head into our documents. Let's head into mastermind. I have no idea what's in this mastermind directory. It has a lot more things because all of the previous courses were done here. So you can see that there's a lot of stuff there. We're going to make another quick directory. I'll sync them all up later. Actually, no, we'll clone it real quick. I forgot we had a something in GitHub, just so we can keep things together. And I don't know if you guys can tell, but this is a much faster experience for me, at least when I'm typing things, than when I'm using the VM. Like, it's so much more responsive. It's pretty wild, actually. And so I tried to give the VM a go for a little bit, but just, you know, sometimes things just don't work out. Just don't work out at all. A function must return a value, else it's a procedure. Sure. Yes. Yes, I'm trying to figure out if I want to submit that, if that's information I want to submit now, but yes. So we talked about functions, they can do return some values. We're gonna contextualize that returning. We're gonna help you understand that returning, they're not required to return any values. What are we programming? We are just learning about functions today. We'll be writing some functions and using all the tools that we've learned over the past 4 weeks to just kind of really understand functions and scope. Scope's very important, so we are going to get to scope tonight. So nothing super important. He got knocked out. Yeah, he probably got knocked out. Are we doing this in terminal or VS Code? VS Code, completely fine. This is, I will call her back. This is my mother. I'll call her back after this. Let's see. What was I doing? I forgot that fast. I was cloning this repo that we already have in here. deCoded. No, not get example. Just so I can put this in here. Not pipelines. The one thing I don't like about this laptop. I love this laptop. Otherwise, the one thing I dislike about this laptop is that the mouse pad is. Gotta be honest, I don't like to always use bad words, but the mouse pad is some boo-boo. Not very good. So we'll take this deCoded class examples. It's a boo-boo mouse pad, and I have a nice, what's it called, Logitech MX Master 2S or something, or 2. But you know what? It's fine. I'll get used to it. So let me clone this. Git clone. And I already forgot what this is called, but I think we'll start it with deCoded. And just so I can keep everything here. So I'm gonna make a new directory. What am I gonna call this? I'm gonna call this functions. And I'm gonna go into that functions directory. All right, so you can do this in VS Code if you want. So just open up VS Code and anywhere you want on your computer and open up a file. We're gonna call this, we'll call it functions.py. So I'm gonna do it in Vim. Just go ahead and create a file called functions.py. And remember, you're using VS Code, or if you don't want to do it that way, head over to REPL. Oh man, it's been a while since we worked on this. Jack Black's Blackjack. This was fun. This was a fun fun little projecto. We should play some blackjack in a second. But you know, head over here and go ahead and get yourself a little new file going right here. To get a new file, or head over to repo.it to do some stuff. What happened to the Model D? I still have the Model D. So I'm still using it's here. That's for my desktop. But I have my laptop going through the capture card in my desktop, and I'm not set up right now to, like, I have a server. I have like a what's that thing called? A Synergy server where I can use my mouse and keyboard on multiple computers, and it works well. I changed all this up right before, so I'm all out of whack. I'm dumb. I don't know why I decided to do that, but it is a better experience for me right now, to be honest. Okay. Well, that was weird. So a function, we're gonna do this in Python. And again, a function is just it's a little packaged up bit of code that can, that runs when called, and it can be used multiple times. So the way that you do it is you use a keyword to call it. So def is going to be the one in here. And actually, we'll go ahead, we'll leave it like this. Def here, and then let's give our function a name. So let's start with the most simple. Again, let's write a function that does the famous hello world square. We'll start with that, and we'll just keep building on top of that. So we'll call this def hello. We'll just say hello. It's gonna be a function that just says hello world. So this right here, this syntax right here, def, call it whatever name you like. The name does not matter at all. You can call it whatever name you like. Open and close parentheses, and then do your little dots here. And this is the function. So now that packaged up bit of code, you have created the package. You have created a function definition, and now everything you put underneath it is going to be the code that runs when you run this function. So nothing special here. It's whatever code you want to run. So how do we, if we wanted to make one that said hello world, again, how would we do that? We already know how to print output to the screen using Python. So the way is to use the print function, and also look at that. Remember how you see these open close parentheses with things like print? It's because print is actually a function. Print is a function that's given to us inside of Python's standard library for us to use over and over again. That print is, there's code that tells that print is running to do what we want it to do. And so inside of here, we're just gonna say, hello world. And now this is an entire function. This is an entire piece of code that will run. So normally we take something like this, we run it. If we did print hello world, we would know that it would print hello world out to the command line. So let's look at that, and let's go Python 3. Do I have 3 on here? Yeah, Python 3 functions.py. And when I hit enter, nothing happens, or nothing that I thought would happen, or that you may have thought would happen. But again, alas, go back to the slides. This code will only run when it's called. So this is valid Python code. It is completely valid. It's completely valid Python code, but I never called the function. I wrote the function. The interpreter, when the file kicked off, when I gave it the file, it read through, and the interpreter understood what this function was. It loaded this into the current instance of this running Python file, but I never actually ran it. And again, how do you call it? You must call it by name. So the way that I call it is simply to type its name. And then so right there, if I just typed it like this, this will be seen as like a variable. So it will be probably looking for a variable, and it will give us a weird error, like, hey, this doesn't exist. But just go ahead and stick on the functions at the end. So basically you're gonna call whatever it's called up here with parentheses after, and this will run your function. And let's see. And you can see here, it does in fact this time print out hello world. And so calling the function is just piece of the code as well. So what happens if we do it 5 times? What do you think is going to happen if we run hello, 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 hello? What do you think is going to happen if we do that multiple times? We'll run it again, and we get it printed 5 times. So again, it's a way to kind of package up a little piece of code. And it doesn't have to be a little piece of code. It can be huge pieces of code, but it's packaged up code basically. And it's not really packaged up code, but it's a good way to visualize it it's packaged up code that you can use again and again, and it only runs when called, and it's really nice. We're going to learn how to use it a little bit better. You might say, oh, that's kind of weird. Like, why, like, all right, that's great, but like, that doesn't seem super useful. Sure, it doesn't seem super useful yet, because I don't know why you would want to do that. But maybe you wanted a function. Maybe you're writing some type of plugin, and just start out. Maybe you're writing some type of plugin that when, maybe we were writing some type of Slack plugin or something, and you wanted whenever someone typed in a certain, number of characters or something, maybe it give, the entire lyrics to a song. And, you can write a little function like this, and you say, a bunch of words. I mean, this is not a bunch of words. I probably should have copied and pasted from somewhere, but you could imagine that there could be a lot of stuff here, and, something that you write once and that can be run multiple times. Again, also a dumb thing to do, but just starting to introduce you to the ways you might use a function like this that does not return any data, that just kind of runs through and does something for you. But yeah, let's actually undo this. So the first thing we have here is hello world, our hello world script. So that's great. And again, we can do that for a lot of other things. Maybe, yes, very simple. That's functions first. We're gonna learn about arguments really quick. Any questions so far? We're about to learn more, about to learn about arguments, so we're about to start really seeing the power of a function. We haven't learned about the power of a function yet. So any questions yet? Can you run an input function? Great question. Absolutely. Yeah, you can. There's nothing you can't run inside of the function. You can run all the same stuff that we've learned so far. You can run it inside of a function. So let's try that again. It's a great question. So we learned about input. That's how you take an input, and you could say, let's say we want to take in the input with the input function. So remember, you remember input looks like this, just like print. It's actually a function, and in there we're gonna put in again, what is your name? All right, and we've learned that for the input, you got to capture. We could run this and it would work, and it would ask us. Actually, check this out. So look at this code really quick. What do you think it's gonna do? I want you to take a little bit of time thinking about what it's gonna do. Like, look at it for a bit. I'm gonna run it. I'm gonna give you like 30 seconds. But it's gonna be weird. This is it's a dumb thing, but it's a powerful thing to kind of just take a look, and in your mind look at what's on there, and see if you can see how you think the computer is going to interpret what we gave to it. Because again, we're giving the computer instructions on how to run something, to perform a task automatically. And so how do we think it's going to do this? Ooh, you're doing your thesis with Python. Nice. What's your thesis on? That's pretty interesting. It's gonna give you an error. It's gonna I actually don't think it's gonna give me an error. Well, let's find out. I don't know. I don't think so, but we'll see. All right, so let's see what it's gonna do. I have input, what is your name, and I have print hello world, and then I have hello, 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 hello. So let's see. Let's try to run it. And we do get an error. So let's read the error. And we're going to talk about errors in the second to last class. I don't know why we're doing it so late, but we are talking about it then. Which says name error. Hello is not defined. Okay, what does that mean? So let's take a look back at our code, and we're looking for the word hello. And look at this. Hello, hello, hello. We're calling the function hello, but didn't we call it hello? No, we changed the name of the function to lyrics. So hello won't work. So it gives you a problem. Remember, the function needs to properly be called by name. So we'll change this back to hello, and we'll see if this fixes it. Now that we are in fact calling the proper function, what do we think is going to happen this time? We're going to call it 5 times. This is the code that the function does. Let's see what happens. Whoa, that scared me. All right, so ask me my name, and I'm gonna type it in. Just hello world. Then ask me my name again. I just gave you my name. I don't know why you're doing that. I'm gonna type it again. Ask me again. Ask me again. Ask me again. Okay. So what it did is it asked me my name. once I entered my name, because in the function we asked for input, in the function we asked for input first, I entered my name, I satisfied that input, and it printed out hello world. So it satisfied this first one, so that goes away basically, and it moves on to the next one, and it asked my name again, and I typed it in again, and you know, it just did that 5 times because we called it 5 times. So you can do an input. Let's say we know we need to save this to a variable if we want to capture that input. So I'll save it to a variable, and I can, you know, I can do something like this. Hello, and I can interpolate this. I think that's how you interpolate, or does it need one of these? I don't know. Never remember. So I can interpolate that so that it'll tell me hello, my name. And so let's see if this works. What's my name? And it does spit out hello, Aaron. So we captured that input. So we were able to use the input that we asked. So that was a great question. I don't remember who asked that, but that was a good thing. Diarrhea. Good question. I'm glad we went through that. So you can do it using input. You can use everything we've learned so far. You can use them inside of a function. So now this actually leads perfectly. This segues perfectly. You made my job much easier. This segues perfectly into where functions actually get a little more powerful. And the way they get a little more powerful is when you can pass data into them. So function arguments, they're called arguments. You can pass data into a function. People all commonly say pass data in, but this is declaring arguments for your function. These are things that you pass. These things that you pass in are called arguments. You can pass in multiple arguments by separating them with a comma. However many arguments in the function definition, however many, sorry, I don't know why I read it like that. However many arguments that are in the function definition must be passed in when calling the function. So let's break that down a little bit. You can pass data into a function. So I can give the function information for it to use for processing. You can pass in multiple things separated by a comma, and this is right now, this is, again, it's for everything, but these specific things are for Python. And yeah, they're separated by a comma. However many arguments, so like it says you can pass in multiple things. If the function needs 4 arguments, 4 arguments must be passed in when calling that function. When you actually call it, 4 arguments must be passed in. So let's see what that looks like. Yeah, before we do the next thing, let's see what that looks like. So you've already done this. And remember, we said input, we said print. These are already functions. And you see, you put something in between. You see how we're calling hello here without anything in between the parentheses? We called input by putting something in there. And so this string that we put inside of input is an argument. This string that we put inside of print is an argument. And so this is data that's passed in. And so when we pass this in a print, print takes this information and it runs some code that was written for it to run, and it utilizes the information that was given to it throughout here, and it gives us back some data. So let's save this file really quick. And let's vim arguments. I'm gonna start a new one. I'm gonna call it arguments.py. All right, and we'll do the same thing. We'll do a very similar thing. So we'll call this, again, we'll call it def. You know what? Yeah, we'll keep on with Python for a second. We'll do def, same function name, call it hello because it's a new file. But this time it's gonna take in a parameter. So this time, before we asked the user for the name, this time we're going to take in that name, and we can still ask the user for a name, but this function is a little more reusable. We're going to take in a name. And so what you can do is inside of the function definition, this function definition, you tell the function how many parameters it's going to be pulling in. So I can type in name right here. And so, whoops. This is simply a variable for whatever, it's a placeholder for whatever you're gonna pass in. This could be X, this could be Y, this could be Z, it could be U, it could be actually your name, it could be whatever you want it to be. This is just a variable in here, it's a placeholder. So, oh my gosh, I forgot I'm not using my keyboard that I'm used to. So name. And so, because there's one item here, that means whenever I use this hello function, I need to pass in one argument. I have to pass in one argument for this function to know what's happening. So like if I do it like this and I say, in this placeholder, it's a variable. So I can do something, I can do the same thing we did last time. I can say print F hello name. And so what'll happen is name will get passed in when calling the function, and then I can use that when it gets passed in, it'll be assigned the variable name basically, and I can use that in my code. And so this is kind of the same thing as last time, but when I call the function, I have to do this. So if I try to call it like this, I just try to call it hello and I try to run it. It'll ask me for interesting. Oh wait, wrong file. Python. I was like, that should break, shouldn't it? And yes, it should. So I go to run it, and it says hello is missing one required positional argument. It's because I told it when I defined the function, when I set up the function, when I set up this reusable piece of code, I said, hey, you should be expecting to get some input. You should be expecting an argument, which we are going to assign to the value name. And down here, it didn't get it. So how do you pass something in? You do it like this. You say, my name is Aaron. I pass in a string like this. So I call the function and I pass in what they tell me to pass in. And I'll save this. I'll run it. And now it says hello Aaron because I passed in some data and it was able to utilize that data. Now let's make this a little more usable like the last one, and you can see how you could use a function like this. Instead of doing this, I could say maybe I want another function. Let's see how we can combine these together. Maybe I want a function that says def get name. Maybe I want a function that actually gets the person's name, and I could do it in the same function, but that doesn't take any inputs. But I could say, oh nope, I can't do this example yet for you because you don't know about the next thing. But yes, you can take in information, but you can also take in more information by doing this. Like I could say maybe instead of just first name, I can do first, comma, last. So maybe this function will take in the first name and the last name. And so I can do hello first, last. And so you can pass in multiple things. And so right now, remember our function definition says we need two things, because we need a first and we need to basically to pass in two items, a first and a last. But here I'm only doing one. So let's see what happens here. Run it again. Check that out. It says hello, missing one required positional parameter last. So notice that it says it's missing the argument last. The reason why it's saying argument last is notice how here it says positional argument. So the position of the arguments does in fact matter. So because we did pass in one thing, it doesn't know what these words are. It doesn't know what you really want, but because this is the only thing that's passed in, it's the first thing that's passed in. And so it gets assigned to whatever that first value is. And since we didn't pass in the second thing, this never gets anything. So I do Brooks, which is my last name. Wow. Gotta get used to the old keyboard. Brooks. Now I'm passing in two things. So Aaron will take the name of first, take the place of first. Brooks will take the place of last. And these values will get used down here. And like that. So you can pass in more and more and more, but the important thing to remember is that however many things are defined up here, whatever the function is defined, however many things it has for you to pass in, you must pass that many things in. So any questions so far about this? We're moving pretty quick, but we're gonna have some fun with this in a second. And let's actually do this in, we'll actually do this in Go as well real quick, to kind of to go over the same topics that we just went over. And so that you can see it's much of the same. We're gonna do it in JavaScript as well. So actually, let me just do a Vim right here. I never remember, what do we do? We did functions first. What? No. I never remember how to do a new file in Nerdtree. What is it? I never remember. I need to start using Nerdtree more. I usually just go out, but I know it's an easy way. Is it Shift M? No. Node mappings, file mappings, open preview. Or is it A? No. I know it's not A. I feel like it's Control M, Nerdtree. Oh, is it here? There it goes. There we go. So I'm gonna add a node called functions.go. So I'm gonna make a new file called functions.go, and I'm gonna copy what we did basically for this this functions.py. So this is the Python we wrote on the right. Let's see what that looks like in Go. What? That was weird. Just setting up that boilerplate for Go. All right, and the first thing that you see when you see that boilerplate code, you've been seeing a function. It needs a function to start. It actually needs a main function, and so this is why we're going to talk about Go a little bit more tonight than usual, or talk about compiled languages, period. So no matter what, you need this to run a piece of Go code. What's up, Wanad? I'm gonna go with that. I'm sorry. Welcome to the channel. Thank you so much for the follow. But this is boilerplate Go code, and notice it has a function. This is called func. That's the keyword to define a function inside of Go. Over here on the left, and it says func main. This is a common paradigm with most compiled languages. It needs an entry point to the program. It needs a place for everything to start, and main is where the program starts for compiled languages. And so you have to have this here. And so we have this main function, but we can add more functions. So the main function is just where the program gets kind of set up. So we can define some other functions up here. What's up, Lafioska? How you doing? Good day. We can make a function up here. So let's make the same hello function. So func, call it hello. And we'll just do like this. So things are not looking crazy at all. You know, you're like, hey, I know this. We just kind of did this. And what do we do up here? We did name input. We're not gonna do input. We're just gonna do the print hello world for now, because grabbing inputs is different in Go. It's a lot different in Go. And so I think it'll make it confusing. And so we'll just set a name. We'll set a name equals Aaron. And we will go ahead and print, not print. I don't know why I keep doing that. Format dot print line. Hello. Plus name. All right, so this is like the same thing basically that we have over here without grabbing the input, but this one in Go, how do we call this function by name? We can call it, but it needs to be in this main function here. And so I simply just call hello. And that's how I call it, because it just needs to be in here. So I'm basically using one function to call another function. And so now you see that you can do that. Yeah, you see that you can do that. So let's see if it actually runs. It should run, I hope. Go run arguments. No, functions. And it says hello Aaron, no space in between because I didn't give it a space because I did not properly why is this this computer, or this, like, it's old, not old, I just haven't updated in a while. It does not have all my settings, but I'll put a little space here. But you can see here how you know, if we open up Darn it. If we open up this and we look at functions.py, like it's not wildly different here. You have the name of the function, you have the function keyword, the name of the function, you have your parentheses, and then some stuff after it. Yes, in Go, just like in JavaScript, there are these curly braces as well to kind of hold everything in. Python uses white space to do this instead, but it's the same concept. It's, for the most part, it is the same concept between the two things. Now let's do some arguments here in this same file. I won't create a new one. I'll just do some arguments. So instead, if we don't want to define this, we can do this. Now, here's where, again, a compiled language like Go differs from a dynamically typed language like Python. Yes, I can take it a name, and I can give it a variable of name, but I have to give it the type as well. I have to tell it what data type name is going to be. Like in Python, this is very important actually. In Python, I put name there. I could have passed in anything I wanted. I could have passed it in a Boolean. I could have passed in a float. I could have passed in an integer. No matter what I wanted to pass in, I could have passed in. This is not the case here, so I must tell it that, hey, you are looking for a string. So the first word is going to be the name, or whatever variable you want to use for it. So again, I can make it X or anything else I wanted, but just to make it readable, I want to make this name, and it has to be a string. And now I can grab more things. So maybe I want first. Maybe I want first name and last name, and I can still separate them by comma, but I must tell it what data type it's going to be. And again, it could be a string. Maybe if I was doing age, I can make it an integer or a Boolean, but I have to tell it what data type I'm going to be passing in. I am not getting the dot online. Oh yes, yeah. Ignore, if you're talking about this here, ignore that. That is something put in by Vim. That is not. It's to show that there's a tab there, a tab character there. So just don't worry about that. Just know that I tabbed there. Those are not real characters. Oh, you mean this right here? Or are you talking about this? If you're talking about why this is here, this was just to put a space in between hello and name, because or else they would be put side by side because string concatenation. But yeah, just the tab. Yep, it's just a tab. I know it's weird. I know it's super weird. Okay, so this time I'm going to take in a string. The hello function is going to take in a string, and I'm going to say hello. Instead of name, because I'm not taking in name, I'm taking in the variable first. Basically, I'll say hello first, and so I need to pass in a name. And the same thing that we did before, I need to pass in Aaron, or I need to pass in just any of these. And so if I run it again, it runs hello Aaron. But let's take a look back at the functions.py. Let's take a look at this one. Actually, let's take a look at the arguments.py. I took first and last. Notice how I can do, if I wanted to not pass in Aaron for the first one. What is this keyboard? What am I hitting? Oh, sorry. There's a difference in spacing between the backspace key and I don't even have a home key on that keyboard, so I'm not used to that. So I can actually pass in something like 30. I'm 30 years old. I can pass in 30 if I want, not a string, if I would like, and this will still run that. So Python arguments hello 30 Brooks. It will work because it's an interpreted language. It's inferring what type I want it to be, and it's working with it accordingly. But for Go, again, that's not the case. I must pass in a string because I said it's going to be expecting a string. If I try to pass in anything other than a string, I will get a big fat error. There we go. Cannot use 30 type integer as a type string in argument to hello. So it's actually a very descriptive error there. It says, hey, you can't use 30, which is a type integer, as a type string in an argument to the hello function. So it's pretty nice that happens. So you must in fact pass in a string. You can pass in different data types. Like each of the types doesn't need to be the same. Like if I pass in multiple things, it does not need to be the same type, but I just have to let it know what to expect. Like I could pass in name and age, and I can make that an integer. And so here, and I can say hello name, comma, let's add a little bit more. Wow, I'm struggling. FS first plus U period. Oh, I'm gonna have to get used to this keyboard so bad. You are plus, a lot of string concatenation here. You know what? We'll make this easier. We'll make this a lot easier. Make it a lot easier. We will say hello percent V, comma, you are percent V years old. Make it cleaner. Make it cleaner. Old. And then comma, and what I want first, and age. Okay. So I can pass in two things, but I need to pass in two things. So here, so again, I put a comma in between, and I passed in a string here, and then I passed in an integer, and that's what I said I was going to pass in, a string and an integer. And let's see if that works. Hello, Aaron. You are 30 years old. It does give me some a marking at the end. This is actually a ZSH problem that it gives me this weird character at the end. But yes, that does in fact work. So we can pass in multiple things. So it's not a crazy amount more code or anything like that for us to be able to run it, but just know that for Go in particular, it does need a function to run the entire program. It needs a main function. Like this couldn't be the stain function. It would never run. It needs a main function to work because this is the main package. Even if I made this the stain package, you cannot run non-main package. You need a main package. You need to have it. Now, there's more caveats to that, but for all intents and purposes right now, a Go program needs a main function. Most compiled languages need a main function to kind of run, and then you can do things outside of that main function, but in that main function is where the essential logic needs to call the things that you need. Okay, so now we learned about arguments, and let's learn about the last piece. So now we can put it all together, and we can start really like playing around with these functions. Like I haven't been able to do a lot yet because I'm trying to hold off with things like this. So getting information back. So it's great that we can write these functions. It's great that basically they're packaging up a little bit of code for us to be able to use. Again and again, we can call again and again throughout our program if we'd like. But what we really want is we want to get information back. So when calling a function, we are usually passing in some data to be processed and looking to get some type of output. In order to use this output outside of the scope of the function, we don't know about scope yet, but I put the word in there just for you, but to use it outside of the function. So to be able to use that data that we create inside the function, to be able to use it outside of the function, we must return it from the function. It doesn't actually exist outside of that function until we return it outside of the function. Multiple values can be returned, but you can only have one return statement. So that may be confusing. What does that mean? So take that in a bit. Take a little bit of water. So what I do here, what's up, Dual Mentor 772. What we do here with this code, we're just learning how to This is an 8-week kind of intro to coding bootcamp. We're just learning how to learning the different tools and things that we have available to us to be able to write software. We're going to be putting all these things together to be able to learn how to solve problems, how to code, different things. So we're going to be using these things starting next week. Honestly, we're going to be diving into algorithms starting next week, and that's not the end all be all, but we will get there. We'll start learning how to solve problems using code, and as the courses go along, we'll learn how to build bigger and better things. Computer gaming or computer programming? Computer programming. Sorry, I don't know if I said gaming, but computer programming. Computer gaming needs, someone has to program those games. So, same thing. Well, appreciate the follow, dual mentor. I want to say dual monitor because it's dual, but welcome to the channel. Thank you so much for the follow. Good to have you. So we need to return information from a function. So this is going to also be your first little intro to scope. We have a full section on scope next, but this is your first little go in this. So return. So I'm going to vim a file called return.py. Okay. Now we just said that the data that is created within the function is not accessible outside of that function unless you return it. So what we mean by that is this. What if we wanted to make a little calculator? So maybe what if we wanted a function that took in two numbers, added them together? We could do that. So we could say, hey, def add numbers. I'm gonna call it def add nums. A little thing that'll add two numbers together. Pretty simple function. So a function that's going to add two numbers together, if it needs to add two numbers, it needs to get two numbers. So how do we tell it that it can have two numbers? And I'm gonna say num1 and num2. Again, you can call this anything you want. You can say x and y, whatever works for you, however your brain works best. I want to be as descriptive as possible here. So I'm gonna say num1 and num2 for these numbers. So the way that we would add these things is you could say, hey, go ahead and add, if that's what the function does, just add num1 to num2. And maybe we can, to see that it does something, maybe we can print that out. Sure. So we can print it out and we can run this. We can run this here. So we can say add nums and we can give it two numbers. We can give it 5 and we can give it 4. So 5 plus 4 is 9. And so we should see this take in 5 and 4, and then that gets passed down here, and it should print out 5 plus 4. That's nice. That's cool. Whoops. And if I say Python 3, what did I call that? I called it return.py. If I run it, check out over here on the left. I know everything's getting a little weird because this my prompt is super long. We get 9, so it does it. It prints it out for us. Great. I'm glad it prints it out for us. That's really nice. But let's go back into this now. Let's say we wanted to add two numbers and then add it to another number. Let's say I wanted to add nums, but I wanted to, maybe I wanted to save that. Like maybe I want to save that value for one, and maybe I want to add it to another number later. Maybe I need to add 10 later on. So maybe I would try to do something like add nums first plus 10 or something like this. So maybe I want to run add nums first, and that should give me 9. I'm going to try to add 10 to it. Maybe I want that to be 19 or something. So let's see what happens here. And that's going to fail. That's going to fail because we get this operand none type, and I try to add two things together that it cannot properly add together. Okay, so maybe that's not right, but maybe you want to say, hey, I want to save add nums to a variable. So when you're running a function, the same way we did with input, remember how we saved the name for input into the variable name? I could say, hey, I can create a variable called sum, and I can set it equal to the value of this, right? And so maybe if I, what happens if I took this print off? The print goes through and it prints out the numbers, but we know it's adding together. If I take off the print, we know it's still adding together. But let's say I try to set this equal to sum, and I try to print out sum just to make sure sum is what we want it to be. So sum should be 9. I say, go ahead and print out sum here. So I'm gonna call the function add nums with 5 and 4, which is going to call this function up here. It's gonna pass in 5, it's gonna pass in 4, it's gonna add those two things together, which should give us 9. And so 9 should get, the sum should be 9 and it should print out 9. But let's see what happens. And we run it, we get none. We actually get that it is, it's none. That's weird, right? You might say, oh, that's super odd. Like, we just add them together, should be good. And this is because these numbers actually did get added together. It did in fact run this function and it added these numbers together. But once it did that, once this function was called and it added those numbers together, that's kind of all that happens. This function is its own little contained piece of code, and it ran those things and nothing else happened. For us to get information out of that, the print was nice because it allows us to print because the print was in here, but we can't use that 9. They're added together, but it's not saved anywhere. Even if we saved it to a variable, it wouldn't matter. What we would have to do is we would have to return that value. So what you would do is you could just put return here. The return keyword is how you get information out. So once you're ready, you can only have one of these things. You can only have one of these statements. It can return multiple values. So one return statement can return multiple values. Sometimes it's with a comma, sometimes it's with a space, depending on your language. But there can only be one return statement. And so, now I'm returning the value of num1 plus num2. And so now if we run this, we do get 9 this time. We get 9 this time. And again, we get this because we are, and maybe it'll make it actually easier if I say sum equals num1 plus num2, and then maybe I say return sum instead. So maybe that makes a little more sense to you because we've been working with variables a little bit. And then maybe I'll change this to sum of numbers just to change up the words. And all right, so a little bit different, but you must, to get the information that's out of here, if you do any type of processing, like right here, we did some processing. We took the input, we added them together. Now we have to create the output. You create that output using this return statement. And so this will always work now. And so what this means is, what's nice about this is now I can do this with a lot of different numbers. I can do it with plenty of different numbers when I do it this way. If I need to use it over and over again. This is now a self-contained addition function that maybe my application can use. Maybe you're writing a calculator app. This might be all you need to set up the addition portion of your code. And then maybe you want to copy this and, maybe you want to go down here. You want to say, subtract nums, and maybe you want to just switch this to minus, or maybe I'll call this the difference instead and return difference. And we are halfway to a calculator. So I have one function that adds numbers together and I have another function that subtracts numbers, and it's okay that I have that. Neither one's going to run until I call them, but no matter what, you must, to get data out of it, to use data outside of this function, which you are going to want to do, you must return it. You must return that data. This is one of the biggest, most common mistakes when people first start getting into this stuff, start getting into functions and start building things, is that they do not remember to return things. They start writing it. They do proper logic, but they're like, hey, I'm not seeing the right answer. I'm not getting information back. And it's because they did not return the data to be used outside of that function. And when you return it, you must capture it as well. So really the return only helps if you're trying to capture it to like a variable or pass it in somewhere else. But yeah, you kind of got to be using it somewhere else for that as well. Yeah, I'm tired. Sorry about that. I'll delete these lines real quick. And now the same thing goes for, let's do vim return .go. For Go, import, there's one extra caveat here. So if I have func main we'll do that. If we have func add nums, and that's going to take in, add nums must take in two things. So num1, and that's an integer, and num2, which is an integer. And we did, what do? We did sum equals num1 plus num2. So very similar here. The one thing that we have to do though, if we wanted to then return sum, this will actually fail, and I'll show you it real quick. This will actually fail. It looks just like the Python one that we did. If I do format dot print line add nums, again, we're passing the same numbers, so 5 and 4. This will actually fail. And it fails because it says func main must have no arguments and no return value. So that might be a different thing. Missing function body. So that looks like I have a syntax error rather than an actual problem. So hold on, let's check that out. No, that's right. Okay, so the reason why it didn't work, is because although we told what we are inputting, we told what arguments we were passing into this function that this function needs. It needs number 1, which is an integer, and number 2, which is also an integer. We also have to tell it the type of the thing that we are returning. So right outside of the parentheses, I have to say, hey, I'm going to take in 2 numbers and I'm going to return a number. And so this is very important. You have to tell it what you're taking in, and then you have to tell it the type of what you're going to be outputting every time, and that is pretty important. Let's do this again. Oops. I missed something here. Func add nums, and I closed it. Func, oh, there we go. That was the problem. But yeah. So let's take this out. That works, but let's take this out and see what error we get when we are not returning a value here. We get this used as too many arguments to return. So the reason it says too many arguments to return is because we basically, with us telling the program that it wasn't going to have a return by not putting the type there, we're basically telling it, hey, we're not returning anything. Like nothing's going to be returned. And so when we try to return something, it says, hey, you know, you have too many things here. You can't return this many things because you didn't say you were going to return anything. So it's pretty interesting. And so if we were going to return multiple things, you could do the same thing. So I would say I'm returning an int and an int. And if I was returning 3 things and the third one was a string, I could say I'm returning an int and a string, and you can just keep doing that after this. But we are taking in 2 things. We are returning an int, and this will work. Dual is fine. I like that. Mentor. No, is that Mastermind the DOS? It's not. It is not. This is my sweet I think I'm gonna step away from this though. I think this is hyper. I think I'm gonna move away from this, but it's just my hyper setup. Just like other object-oriented language declarations, except data types come after the name instead of before. Correct. Yes, data types come after the name instead of before. That's true. Yeah, so I think I was about to show you something different here with Go. What terminal are you going to try out next? So that's a good question. I've seen so there's a really fast GPU one that I don't even know if I can use on this laptop because it does not have a dedicated GPU, called Kitty terminal. Oops. That I've heard some pretty good things about, and I've checked it out. It looks fast. It looks pretty nice. I don't know. The only reason I might move away from it, one is so on Windows, WSL2 is nice. I'm using it on my laptop now. It is phenomenal, actually. I'm very impressed. So I use Windows Terminal there. I don't think Windows Terminal is open source. Like, I don't think it's available on Actually, I might stay with Hyper. Windows Terminal on Linux. That seems weird that I could even try to search for this. But I wonder, yeah, I don't think you can put it on Linux, even though it is open source. The Windows Terminal is in fact an open source application. If anyone's interested in checking it out, but you cannot install it on Linux, unfortunately, or at least as far as I know. You can, but yeah, I think I'm gonna try out Kitty Terminal or something. I've tried a bunch in the past. I do like Hyper a lot. It works well on this laptop. It does not work well on it does not work well on a lot of other computers that I have. It's pretty hit or miss whether it'll work or not. So I don't know. I just want to give some other things a try. I like to mess with things. That's what you use. You use Windows Terminal, or you use Kitty Terminal. That's pretty cool. Did you see Windows got a package manager? Wing it, like someone told me about it. That's pretty dope. Oh, you use Kitty. How do you like it? Maybe do you have any cool settings or things that I should know about before I hop into it? Yeah, I saw that. Someone here told me about that, which I think is pretty dope. Windows is really, I'm telling you, they're making themselves a viable platform again for somebody who makes. I love Linux. I really do love Linux, but for someone who is creating content, someone who programs, someone who plays games, like this is making Windows the ultimate one OS platform for me, at least, because I always use Linux for coding and development, and I would use Mac for some other things. Well, I would really use Windows for those things, but content creation, so when I want to do video editing and stuff, it's terrible on Linux. But I prefer Windows because it has gaming as well. So like Macs are kind of the best. Well, people assume they're the best for content creation. And then when it came to gaming, you got to go Windows. Like there's no really other options. And so really Windows is now it's really becoming the kind of the best all-arounder. It ain't perfect by any means, but for me, it's becoming the best all-arounder. Also because I like to build my own computers, the best bang for buck. I like to upgrade over time rather than, buying computers all at once, buying brand new computers. I prefer to go the Windows route for that reason. Hardware's a little bit, more bang for your buck. But I don't know. It's pretty interesting. I'll probably continue to use Linux for the streams though. This laptop will probably become purely just here for the stream. But yeah, we'll see. Okay. So that is that. So next thing we're gonna talk about. Actually, just show you again that you can use functions can be used to call other functions. So maybe let's do something. Now that we know about returns, let's do this real quick. And I did not say it earlier. But for sure tonight you will be out of here real early. I don't want to get your hopes up in the beginning and let you down again, but with the pace that we're going at now, letting you know, you'll be out of here real early. You get some time back with your family, get some time to go watch whatever it is that you want to do, catch up on Netflix shows or whatever. And it should be, and I'm going to use that time also, which I'm kind of glad about, to kind of get, I still haven't gotten the videos rendered out from last week to go up on YouTube. So I need to click the button on that render, and get some other things done to make sure you guys have all your stuff. But, I'm willing to say it now because we are, an hour and a half in, we're hour and 15 minutes in, and we're right on pace to be out of here a solid 30 plus minutes early. So, some days some days things work out. Okay. We might take a little bit of time to do one extra thing, since we might have that much time left. One, I want you to see that you can call functions inside of other functions. So I'm gonna make a file really quick called I don't know, function2. No, that's whack. More descriptive. Naming is the hardest thing that you can do when you get into programming. So vim nested functions. Cool, perfect. Thank you very much, Yinray, thank you so much for that, because that is a perfect name. You are a better namer than I am. So nested functions. Let's kind of go back to what we were doing before with the the name or the hello one. So hello, which is going to take in a name. And it's going to print out, it's going to print out, I keep hitting the home button. Okay. All right. Now I know which key I'm hitting. I was very confused about which key was causing me problems. Then we can say hello, name here. But then we can have another function. We have another function in here. I'm missing something. We have another function in here that does get name. So maybe I have one that says def get name. I'm just gonna show you some different ways. Like, yeah, we're gonna do some nested functions. We're also gonna do just using multiple ones here. Get name. Get name is not gonna take in anything at all. And it's gonna use the input. Return input of what is your name? Space, question mark, space. What is your name? I'm gonna ask what your name is. And so this is just two functions. So first I'm gonna show you how to use just kind of these two functions to get what you want. And so this is going to be nested functions in two different ways. It's going to be a function calling another function in the call, and then we'll do one where the functions are calling other functions in the definition. So I can absolutely show you Fibonacci with recursive functions, and we'll do that. So that's fun. Funny enough, we'll probably do that. We will probably do that. Maybe we'll do that for fun at the end of next time. We'll talk about functional programming, and we'll talk about recursive functions, and we'll talk about some of those other things as well. But we could. So yes, this is unexpected in the file because I did not close my return. And then now, so this can be a little confusing here. So I have two functions here that I want to use in conjunction to do what I need to do. So there's a couple different ways I can do this. One is obviously I want to run the get name first so I can get the person's name. And I probably want to save that information and then use that information to print out hello and their name to do their greeting. So let's do this in the, in the easiest way possible would be maybe you want to set up a variable called name, and you set that equal to get name. So if you set that equal to get name will run and it'll ask for the person's name, and whatever I type in, that value will get set to name. And then what do you do? After that, if you want to use the second function to print stuff out, you can call hello, and you can pass in the value of name because we just got name here, and we can pass in that value here, and hopefully it should print our name. So this will probably work. Python 3, that's the functions. What is your name? My name is Aaron, and it does in fact say hello Aaron. So I use two functions to get what I need to get done. And this is commonly how you're going to use these things. You use different functions to get different data and to move things around, and you'll kind of use them together like this. But I could also do this in kind of a one-liner, I think, with doing this. I'm gonna have to I don't know how to do that. I call hello. Yeah, I can call hello. That's great. But can I pass in? I actually don't know if this will work. It should work. I can actually pass in a function as the input. Why? Because this input is gonna basically give me a string that I can pass into here. So I'm gonna call a function inside of another function, and let's see what happens when we do this. I don't know if this will work here. It's not gonna work in, well, we'll just see. And so far so good. This is not this is not a nested function. This is not a nested function. We're just doing, maybe you could say this is nested function calls. I wouldn't call this a nested function though. I'm gonna show you that in a second, but this is nested function calls. And so what's my name? And it says hello Aaron. So we didn't need to do that first piece where we captured it separately. We called one function in another function. So yes, I guess it's actually exactly the same as what I'm going to change it to. So yes, this is in fact nested functions. But the definition features correct. Yep, exactly. But maybe we'll do that. But like, I guess it's technically the same thing. But the hello function, so basically what you're seeing here is the hello function is running. It's actually executing, but it's calling the getName function. So, or it's using the output of the getName function as input to the hello function. So it can get a little interesting here, and all the little parentheses and things can get pretty confusing. But you've also seen this before as well. You've seen this before when we were doing like the getting the length of arrays and stuff, and the length of lists, and we were printing those things out. It was in fact a function inside of another function. So that does work. But I could also do something like this, like instead of doing this down here, I could leave this as hello, and I could only call hello as the thing that I call. And then in the hello function, the first thing I could do, I could do this instead of maybe I take in nothing in the hello function. I take in absolutely nothing, and the first thing I do is call getName. I do name equals getName because we're using name down here. So maybe the first thing I do is have this function use another function that we have. So it's going to call the getName function, and then we are going to go ahead and print out. Now, this is going to be interesting. So I'm going to run this really quick. I'm going to run hello. I think this is going to be interesting. Oh, never mind. It's not going to be as interesting as I thought. What is your name? Aaron. It still works. I thought this, I was just kind of thinking through quickly that maybe this might not work because this is a interpreted language, and it kind of goes through line by line. And I was thinking maybe because I did not define getName first, maybe it wouldn't work, but it works just fine. Just kind of thinking through some of those things. But yeah, so now I am calling getName is actually never being called by itself. It's actually being called as a part of the hello function, so they're kind of tied together. And this is also another paradigm is, helper functions and things like this that only get called inside of other functions like this. And so we do it all again without ever having to do it here. So there are a lot of different ways, as you can already see, to achieve a goal. And this is the reason programming would be a lot easier if there was a way to do something. People would learn how to do that way, and people would take their time and get really good at a programming language just by learning, memorizing all the different ways you could do things. The reason why it's so tough is because there are 47,000 ways to do the same thing. Are some options better than others? Sure. Depends on so many different factors that a lot of the arguments that happen over the structure of code, or the reason they're having that argument is because there's no clear cut answer. Everyone has their opinions for different reasons, but you can see there's a lot of different ways to do that. Compiled and interpreted, that's really comprehended language. Yep, that's it. Here's where I get lost the most. What's the difference between nested functions and function overloading? So for my understanding, and this is a good time to Google, for my understanding, function overloading is when, actually, I'm not even going to tell you because I don't want to confuse you by saying it first and then you attach to that. Function overloading is the ability to create multiple functions of the same name with different implementations. So function overloading is, yes, this is what I thought function overloading was. And so when we get to the object-oriented programming week, we'll be learning about this a little bit more. And so this actually, function method overloading, this is more like a polymorphism a little bit. This is more this is different. The difference between nesting functions and function overloading is that you may to implement some of that function overloading, that's fair. You may do some of these nested functions to do so, but nested functions are simply setting up normal functions and utilizing the functionality of a function in another function. Function overloading is basically it's basically changing the way that a function operates depending on the input that's happening. So it's a little bit different. It's a little hard to explain until we get into, again, that object-oriented programming stuff. We will cover that and that polymorphism. That's a great question though, but they are different. Function overloading is basically a function having different outputs based on different use cases. A function should generally, it takes in data, it does the same thing, and it puts out data. So if you have the same input, you will get the same output every single time, or unless it's like a random number generator or something. But the function overloading is a little different. You're changing those things inside. Let's see. Okay, that was a great question actually. Okay. Now let's learn about scope a little bit. Actually, let's do, you can do the same thing in Go, so that's fine. We'll come back to that. We'll mess around with it a little bit. I think we'll have a little more fun time messing around with scope as well, so we can dive into a little bit. Let's learn about scope. Scope is something that'll bite you a lot. It's very, very important and what you're going to be doing. And let's see, we're going to use this to do it because out of all the things that I've seen, this is the best simple way to set up a thing where scope is, a thing. So let's see, mastermind pop out. Is it chat? No. Is it how do I do this? Hold on, activity stream manager is chat. I'm new to this stuff. There we go. So I shared that. That's in the slide. That you can also just click on it if you're in the slide. But what that'll do, that link is a cool one. And this one, again, is particularly, I am highlighting the specifics from Python because I think for people who are brand new, I think it's going to be good for you to start to understand these things in the context of a singular language as we're kind of diving through. But this is a concept that matters everywhere. And all scope really is the kind of plane in which you exist on and what that plane has access to. Basically, what is in the realm that you're currently in. So there's a little thing here showing namespaces, and namespaces, we're not going to separate them right now. Namespaces and scopes are different things, but for all intents and purposes tonight, they're going to be the same thing. And so you see this outside circle, this is built-in namespace. So this is the built-in scope change namespace to scope. And so this means everything that's built into Python is included in the entire built-in scope. So the way that we can just use the print function, these are kind of the built-in namespace. I have that. That's available to me no matter what plane I'm on. Then we have a global namespace. So as you go in on scope, it reduces the amount of just like on a project. If you're talking about the size of a project or something, you talk about scope creep. It's the amount of things that that project entails. Again, this is kind of the same. And so the global namespace is kind of the global space of the application that you're writing when you open up that file. That it's what is available to everything that's not the things that they're built in the built-in namespace. They're also a part of the global namespace as well in this instance usually, but it's usually the entirety of the file as you create it. And then you gotta dive down a little deeper and you have things like these local namespaces. So local namespaces are smaller pieces of your code where information is kind of it's kind of enclosed. So see how as you get smaller to each of these namespaces, things are kind of enclosed in here. And so something that is enclosed in this local namespace may not be available going outwards, going to, you know, higher up into the namespaces. And so it's a little bit easier to see once you kind of dive into it. But I really like this one because they give us a, where is it? It's in here somewhere. They give us this little function. It's I think it's a bunch of for loops. No, this it's simple. It's just this right here. And let's go with this. Let's copy this. I really like this one. And we are going to vim scope.py. And this takes, I do think scope takes a little bit to really get comfortable with. But what it says here, it says variable 1 is in the global namespace. So global is just going to be the top of the file. And again, especially for Python is a language where it determines its scoping based on white space. And so for Python, everything that you have all the way up against the left edge, everything that is in the, you know, the very left edge of the starts, you know, normally as things start, if the text starts all the way to the left, these things are in your global namespace. If you put anything here, it's in the global namespace, or you should be trying to call it from the global namespace. When I indent in, and when you see me do things like when we created those functions and we indented in, var2, it says it's in the local namespace. So var1, which equals 5, which is right here, it's in the global namespace. That means it's available globally in my program. Anywhere in my program, I can reach var1. I can use var1 anywhere in my program. Now, def, some function. Now, var2 is in the local namespace. What this means is var2 is now only available, it's only available here and below. And then we have, so var2, I could not call var2 on the global namespace. So watch this. Actually, maybe hold on. Am I tripping myself up? Hold on 1 second. Let me try to print down here. Oh, this is some function. Let me call some func. My mind just broke with this example really quick. Some func. But I would have to also call some inner func. If I call this, nope, I don't want to call that. Let me think really quick. My mind just broke. Let me back up a little bit. If I define a variable inside of this scope, or even this scope, yeah, it is not available. It's only going to be available downwards and not upwards. So if I run this, let me actually run this and let me see what they, I remember, you know what's funny? I think we ran into this last time and I was like confused about the way they did it. Yeah, here we go. This is the picture I wanted to see. Object must be present, namespace 1, 2. This is not the one that I thought it was going to be, but let's just see this. Is this what I want? Def some func print. Actually, this is the one I want. This is the one. Sorry about that. I think this is the one that I want. Yeah, I think that's the one that I want. So I'm gonna delete all this real quick. I don't think this is what I wanted either. Hold on real quick. Maybe I wanted the one from W3 Schools. I want to make this the easiest possible because this can be a tough concept. And I don't want to give it to you in a way, I think W3 School, whatever I thought I was going to be using, it gives it to you in a way that is pretty clean. The example's pretty clean. And whenever I created my own, it was gross and it was confusing. Yeah, Python scope a little bit, local scope. No, I don't care about this. Global scope, global keyword. No, I thought there was. All right, well, it doesn't matter. We'll still use this. Okay. Let's grab this. and let's just build off of this. No big deal. I remember there being like a 5 level one that was like really nice for showing this, and I thought I had it, but I don't. 1D. This keyboard, it's killing me. Okay. All right, and so now I don't have all quite the same cool spacing. Def my inner function. Let's get it lined up for how my computer likes these things to be. All right, so let's take a look at what we have here. Sorry about that long setup. They're defining a function called my function, and they're setting up a variable x, which is equal to 300. And then they're defining another function inside of another function. Now, you probably didn't know that you could do that. You're probably like, oh, that's really weird. Notice they have this def keyword here, and it is inside this function. So inside of my func, they're defining an inner function. And then what they're going to try to do is they're going to try to print x, and then they're going to try to call my inner function. Let's see what's going to happen here. And actually, I don't think my inner function is supposed to be here. I think my inner function is supposed to be here. I believe. Let me see. Let me make sure. Yes, I am correct. I was like, hey, that doesn't make any sense the way they had it, or at least the way I had it. So yes, I'm correct. My inner func is supposed to be here. So let's see what's going to happen really quick. So run this. And it prints out the number 300. And let's talk about why I printed out the number 300. So we called my func, so we set x equal to 300. But when we got down to this inner func, we created a brand new function inside of here, and we said print inner function. And then we called that inner function right here. We called the inner function here, where in my function, and it did in fact print out x. And this is because scope gets passed forward. So this right here is in the global scope. Anything all the way on the left is your global scope, and then this is going to be local scope or namespace 1. So the first indentation in is going to be your next namespace. It's going to be your next space for things, and so things can move to the right. Things are available to the right. So things are defined up here. Things are that are defined up here, like x. If I defined a y here, equals yes, this would be available in everything moving to the right. Well, it wouldn't be available globally. It wouldn't be available to things to the left, but only to the right. So if I had another function in here, or another thing in here where I defined, def inner func, and I did something in here, I would have access to x and y, and I would have access to anything I did here. If I did something z here that said the number was 4, I would have access to x, y, and z over here in this inner function. But if I define z here, I will not have access to z in this bigger function. In my function, I cannot print. So watch this. Let's actually do that. Let's delete this to make it a little less confusing. So before, we just had this, and it was able to print out 300 because it set up this here, it printed it out down here when it called it right here. But if let's say I did this, and I did y equals 500, and down here underneath, after it prints the function, what is happening? I'm breaking everything. Oh. And underneath here, I want to go print y. I try to print out y in the same thing. Check out what happens when I try to run this. And it runs through. It does, in fact, print out 300 here up top. So it does what it's supposed to do. But then it runs into an error that says name y is not defined. And this is because I'm trying to call it in a scope that does not have access to this variable. I'm trying to call it in this scope level number 1. I'm trying to call it here, where you can see my cursor going up and down. I'm trying to call it on this scope level, but it's not defined until in here. It's not defined until you get a little bit deeper. So right here, it does not have access to y. So as you move farther to the right, these variables and things get passed down. They can be accessed in other scopes. Whoa, what's up, Core X? Thank you for the gifted subs. Let's you get VIP for that. Really do appreciate that. Thanks for coming in hot with the gifted subs here. How are you doing tonight? Let's get you that VIP real quick. Your name's gonna be hard to type. It's gonna be tough to type. You're gonna, especially on this new keyboard and everything. Let's see. VIP X Core. I'm pretty sure the X Core X. Oh, actually, that wasn't very hard at all. VIP, you're now a VIP of this channel. Really do appreciate it. Thank you so much for the gifted subs, everyone. Thank X Core X for the gifted subs. Really do appreciate it. Thanks for the support. Absolutely. Right now I'm trying to fumble through these scopes, or at least how to explain them. It is tough. It's tough to explain what and where can access these things. So the namespaces are important. I do think this diagram right here is pretty helpful. It is helpful right here. So moving from the top, again, as you kind of move down, things have access to your variables. So everything has access to the built-in namespace. And then as you get deeper, everything else underneath has access to the global namespace. And then as you move deeper to the local namespaces, and you can put more local namespaces inside of here, the circle gets smaller and smaller as you indent farther and farther. But when you start the project, when you start that, open up that file, you are on the global namespace right here. And every time you indent, basically, in Python at least, and most languages, you are now in a different namespace. So it gets a little frustrating. It also works. This also works with things like if statements and stuff too. It's really interesting. I'm trying to find. Give me a second. I'm gonna see if I can find that good example. There's a really good example of scope that you can just like paste in and kind of mess around. Scope in programming. Yes. I learned a hard lesson about scopes when learning Java. Yeah. Scoping is let me see. Scoping and programming example. Yeah, scoping really does, like, it's almost all the problems that I run into now. Usually the ones that I run into trouble are usually because I need to figure out how to get something in scope, to be honest, of what we're doing. I'm trying to get it onto the plane in which the place I'm trying to access it knows about it. Hold on, let's check our GitHub, because I think I pushed up something last year. Maybe we can just use that. Let's see. I thought that website was the good one. I'm hurt that it's not. I think that's the problem. I was sure it was. I believed in you. We called this Python Bootcamp. Oh, we pushed it up. Modules, errors, file operations. We did a bad job of naming last time too. So I don't see it. I don't see it in here. Exercise high score. Functions, maybe functions. Scope, yeah. Check this out. Okay, this is, oh, well, we'll copy this. This feels like it, but yeah, it does. It shows us some of the stuff I was trying to show. So I'm gonna delete all this. Maybe this will help. Maybe it'll make things more confusing for you, but who knows? Yes, and we commented out some things to kind of see what would happen. So check this out. So this is actually the same setup that we were looking at before, a bunch of extra stuff, 100% a bunch of extra stuff, but we put these here to try to see where we had stuff available to us. So var1 right here, variable 1 is available globally. This is the global namespace. So anything far to the left, everything in your program is going to have access to it. Everything, anything you can call it. But again, as you move to the right, only things that are on the same level or farther to the right will have access to it. So var1 will always be available. So I'm down in the second scope level here, the second namespace. If I try to print out var1 here, that should work. I'll leave var1 to print out here. And actually, no, that's what this was. That's what this was. It was show you which things can you print out, which variables can you see. We have variable 1 here, variable 2 here, variable 3 here. Why do we change this? That was the first thing we did. 3 variables, 3 different levels, 3 different scoping levels. Again, variable 1 can be seen on 2 and 3. 2 can only be seen at 2 and 3, and 3 can only be seen at 3. So the only place that I can print all 3 of these variables is if I print them here in the innermost function, in the function that's scoped in the most, that has everything, is the only place that I can print all 3 of these variables. And so we'll run this really quick to see that we can print all 3 variables. Line 7, inconsistent use of indentations. Oh, interesting. Oh, that was just had to do with the paste parameter. Oh, it needs the same. This is, why did it paste like this? It's fine. There we go. This also needs it too. This is just formatting. Nothing else. Oh man, I gotta do it for all these. That's whack. There's a command to do all these, and I can actually delete all these lines and actually take this back 1, take this back 1, all of them. I could outdent everything, which I should just do. And it looks good. Whack, delete this line, some inner function. There we go, this should run. Okay, so when I try to print out everything, what just happened? Let's remove this line really quick. Get into a space where it looks like what it did before, and in this sum inner function, we're calling some inner function right here. We're basically going to try to print out var1, var2, and var3 in this inner function. Let's see what happens when we try to print this out. And nothing prints out. Okay, very interesting. Oh, that's because this is on the wrong line. Sorry. I was like, this should work. And when I do that, I get 5, 6, and 7. It is the only place that I can do this. So if I try to print out all the variables here, just notice what does get printed and what doesn't get printed. So I'm going to actually remove this, and I'm going to put this on the global scope now. I'm going to try to print out everything on the global scope. Actually, what I want to do. No, undo. I want to, actually, I'm going to delete now because it's going to save it to this over one. Oh my gosh, the keyboard. Some inner function. What's all this extra, all these extra giblets? Paste it, V, get over there. What is this? I did that yesterday too. Don't save. I'm struggling over here with this keyboard. It is a little different. I'm gonna delete this line. Delete this line, I'm gonna delete this line, delete this line. Okay, so now all I did was move. I moved the print statements from the second namespace, really, which was over here. I moved it to the global namespace, which is all the way to the left. Remember, the left is where if it's defined there, that's where everything should have access. So if I try to print var1, which is here, which is in the global namespace, var2, which is here in the first namespace, and var3, which is here in the second namespace, let's see what happens when I try to print that. And it prints out the first one. It prints out var1 because that's in the global namespace, so we have access to that. But as soon as it gets to var2, it says it's not defined. Again, as you go to the right, you have access to those things, but access does not travel backwards. So if it's defined here, it is not available on the global namespace. It's defined here, it's also not available on this namespace. So if I try to copy this stuff here, I try to copy it here to the second namespace. or the first namespace, whatever. I should print those out. If you're thinking through these things, now I'll have access to two variables. I have access to var1 and I'll have access to var2, but I will not have access to var3, which gets set up down here. I will not have that. And again, it prints out the first two, but it says var3 is not defined. So very, again, a concept that can be kind of confusing because it has to do with, indentation matters, especially for Python, and like the kind of structure of your code matters in terms of scoping. It's what determines the scoping, and what is inside of what's running inside of what, which is pretty interesting. Other languages, yes, the indentation cares for it, but also things like the curly braces. That's what the curly braces are for. So there are actually ways to format other languages that where the white space isn't the thing at all, but if it's in another set of curly braces, that means it's scoped. And so let's actually take this and put it into Go a little bit. I'm gonna yank this. It's gonna be a little bit more confusing, and I'm gonna yank it. We'll see if we can do this easily. If not, we'll abandon it, because I still want you to get your time back. Import fmt func main. All right, paste. I'll have to do this a little bit different, but I'm just going to this is gonna be gross. We'll do it anyway. Some func. var2 should be in there. This is right, even though it's not print, no problem. It is format.print line. If we get this right the first try, we're gonna be the coolest people who ever did anything cool in their lives. We're gonna delete these for now. Yank X. Func. Some inner func. var3. That feels right, but then I need all the things. So this is where these curly braces get really confusing. So if I have one function and it needs to, if everything scope actually is actually a little more easily seen, actually, I guess, in a language like this where the curly braces matter. And so that'll mean that this function, for like, you can clearly see that this function is inside of this function because it'll be encased basically in these curly braces. So I have curly braces here that encloses that function into that function, and this function will be right here, and it'll enclose this one like this. So again, white space doesn't matter, but this will actually be things encased in other things, which is kind of nice. This is not going to, I don't think it's gonna work, but let's go back to this level 3 where it can print out everything, and let's try to print out everything. Print line var1, and let's take that, and let's do 2 and 3. Okay, let's see if this works. There's no chance, actually. Because I think I need to outdent everything even more, because I'm trying to call some func on the global namespace. Yes, you should be confused. I'm sorry. I went down the rabbit hole, and I knew I was going down a weird rabbit hole, but I had to just like keep it going because I was already starting. Now this is for my, you should absolutely be confused. This is my fault. Go run smope.go. Ooh, look at that. A lot of problems there. Expecting some funk, expecting open. I'm missing some things. Some funk, open. Oh, I never closed some funk. That one. No, that's right. That's right. Okay, I don't know what I did. I was just messing around. Messing around to have a little bit of fun, but it didn't work. But what I was trying to do basically is just kind of convert what we did in Python. We copied in Python over to this. Funk, some inner funk. What I do here? Stuck in the rabbit hole. Yeah, pod committed. I like that. I like that one. He's trying to print 5, 6, and 7. Yeah, we did another one. Yeah, I was just trying to convert. I was trying to convert the Python thing that we had into Go, so that if someone wanted to take a look at it and see how they compared and play with both of them, it could help. Because again, Python scope is defined by white space. You define the scope by the white space. So you know, the indentation things matter. For something like Go, it's yes, the white space is there, so it kind of helps. But it's actually more so defined by encapsulation, and being encapsulated in between the curly braces. So I was hoping to show it a little bit easier, but no. I mean, it would probably work better if I did it outside of this. Funk main, some funk is there. Some inner funk. Am I calling some inner funk at the wrong place? Some inner funk needs, oh, yes, I am. Yes, I'm doing, hold on, let's see. This needs to be here. It needs to be right there. All right, maybe that'll work. Maybe that's all I need to do. Okay, I got rid of one error. I got rid of one thing. Line 8, expected some funk, expecting open parentheses, non-declaration statement outside of function body. On line 23, non-declaration. I called some funk. And 8, funk, some funk. Did I close this one? I did. I closed that one. I closed this one. Oh well, I ain't sweating it. I'm just joking. I'm not joking. I got sent down the rabbit hole. Well, the goal tonight, simply scope is difficult. What I do want you to go to is the page that I provided for you. And don't look at this one. Look at the scope. I even spelled that one wrong. I called it smope.go. It says scope.go. This is the one that you want. Make it a little bit easier, and you can play around with this one. This one's nice because it'll just show you. Don't look at this one. I just don't look at it. This one, you can kind of mess around with where you're printing things out to see where things are available. And again, that's all I want you to know about scope. I don't necessarily need you to be a pro at scope today, but I want you to know that there's a thing called scope, and it determines it determines a number of things. But for our intents and purposes right now, what we care about is it's going to determine what in our code is available to us at what point. Where code is available to us. So again, it's something that might not make a lot of sense until we get into some of the things that we're going to be doing. We are going to be utilizing scope once we get to algorithms on Thursday. So yeah, 100%. It's pretty interesting. Would you use a scope to create a decision tree in Python? Yes. Yes. That is what happens when you do like a if statement. What's up, Actual Tom? Thank you for the raid of 9. I'll let you all get through your ads, and then I'll say what's up. But everyone should be able to. I'm pretty sure I don't have follower mode on, so everyone should be able to say hello. How you doing, Actual Tom? How you doing tonight? Raid day. It is raid day. This is the second or third raid today. I appreciate that. Welcome everyone from the Actual Tom channel. We're actually wrapping up a little bit early tonight. Usually we go until around 9:30, but today we're just talking about functions. We're learning how to, write little reusable pieces of code that only run once they're called. So we learned about functions a little bit. We're going over scope right now, a little bit, kind of understanding scoping in applications. And yeah, y'all love the raid button. Y'all love raid stuff. I love it. Welcome everyone to the channel. That's right. Come on in, get comfortable. We are just doing a little bit of learning. What's up, Pawn Muncher? Pawn Muncher. You know, when there's your name is written like all the SpongeBob memes, and it's hard to read when it's like that. Navy man, Santa left you something, sir. I don't know what that means. I don't know if that's to me. But what's up, everyone? How you doing? All the raiders from Actual Tom. Really do appreciate the raid. Let me give you a little bit of a shout out. I'm getting better at remembering to do these things, and I need a button to like SO. Oh my gosh, new keyboard. I was already on the struggle bus with typing, and now I'm on super struggle bus. Actual Tom. That seems right. That's really small. I can't really see it. But there we go. Everyone check out Actual Tom. I really do appreciate the raid here. All right. So what are the tangible takeaways from tonight? I'll give you all, I'll try to get you all on, I'll find a video or something that explains scope a little bit better, because we are going to be diving into it. It's something that I think, again, that I think you'll be able to pick up as we're kind of learning how to run through some of the problem solving things. And I think the understanding scope is I don't know the hard part. I think understanding it while you're programming, like why you do or do not have access to something, is pretty interesting. But yeah, we'll get that in there. So tangible takeaways: 1, what are functions? Tonight we just want to talk about what functions are, and those are those reusable pieces of code that only run when called, which is great. We also learned tonight that besides that, we create a function using a function keyword. So we define the function via that keyword. In Python it was def, in Go it was func. In JavaScript, it's actually the word function, but it looks the same. And those parentheses are kind of what you should be thinking when you see those. That's kind of how you know something is a function. Really nice. You define that function like that. We also learned that these functions only run when called. And how do you call that function? You call it by name. You type in the name, you put those parentheses after it, and it will run. And so it'll run the bit of code that you wrote for it to run. We also learned about function arguments. We learned that you could pass in data to a function. You could take information and you could pass it in. We learned that in languages like Go, which are statically typed, not only do you have to pass in, the function, but you also have to pass in the correctly typed function. And so how do you know, where do you set that up at? You set that up in the function definition. So inside of those parentheses, you set up a placeholder value, a variable in there to accept a parameter. You have to pass in the number of arguments which are defined in the function definition. So I cannot, if a function is expecting 3 arguments, I cannot call that function with only 2 arguments. I need to call it with 3 arguments. And that is where I want everyone to kind of go back to some of the other things we learned. That is where those empty values come in. If you are working with something and you don't have a value that you need to pass in for something, but you still want to use that function, you can pass in empty values. So if I'm supposed to take a string, I can pass in an empty string value or something like that if I need to, but that's we'll get there during algorithms. But again, you have these things that you can pass in, and you must call the function with the number of arguments that was expressed in the function definition. And then we learned that that information that happens in the function, it kind of only exists within the scope of that function. And so this is where scope matters as well. That data, any kind of processing you do, only exists within the scope of that function if it was kind of created there. And to get that out, to be able to use that in other places, you must return it. You must return that stuff. So actually, to go back to our example here, we would be able to use these things. I would be able to use all of these. I would be able to use all of these on the top level if I don't even need to call some func down here, or underneath some func, I will paste these. If I use that return thing. So these are functions here. If I return var, so if I do return var2, and I also return var3, I can now use these. So if I run this, it should print out everything. Should. you know, sometimes I'm just running by the seat of my pants and this may not work, but I'm pretty sure it'll work. var2 is not defined. Where did I call that at? Maybe not. I might have to call it on after some funk. I might have to call it in. No, that feels. Oh, it's because. Actually, this feels like it should work. Oh, hold on. X. I think this needs to actually go here. Maybe. Let's see. Okay, so got 2 now, but not 3. Or it just ran into the wrong thing. All right, we'll figure it out later. But you can return. This is why you shouldn't go by seat of your pants. But you can return values out of functions to be used in other scopes. To be used in scopes other than the one that the function is referring to. So just, you know, gotta when something pops in your mind, you gotta just try it out. I told you, mess around. I can't tell you how much I've learned by just doing that. I do this every day. People who I'm pairing with at work, I can tell they get upset with me sometimes because I'll get a little idea, and a lot of people like to think through a lot of their problems. And yes, think through your problems, but if you're at a point where you're trying to figure things out, if it's not gonna hurt anything, go try it. You need to end in the return var3. I'll check that out. Yeah. So I was probably super close, but we just moved past it. But getting information back, you can use return to be able to grab that information out and use that information outside of the scope of what you are currently doing. So that's very important. And again, just we learned about scope as well. So those are the main things for tonight that you need to learn. Now going into next week, I want everyone to actually be mentally prepared for when we get into things next week. So not next week, on Thursday. We're going to be diving into algorithms. It is going to feel, I think it's going to feel uncomfortable moving from the way we've been working on things to that. So on Thursday, we're going to basically learn how to approach algorithms, and then we're going to start diving into doing them ourselves. We're going to be hopping into a site called Exorcism and grabbing some that we can work through together on there. But we will be utilizing, again, you know, all of your data types, so strings and integers and Boolean values and things like that. We will absolutely be utilizing those conditional statements. So things like, you know, greater than, less than, those conditional operators, greater than, less than, greater than, equal to, less than, equal to, you know, just equal to. You'll be doing some addition, subtraction, you know, you'll be doing a little bit of math. You'll be using modulo. You'll be using assignment operators, plus, equals, minus, equals, things like that. You'll be doing control flow. You'll be doing those conditional statements, the if statements. If this should be true, do these things. Maybe you'll be using case statements as well. It's kind of your choice, but we'll be starting to put together all the tools that we've learned before. We'll be using functions absolutely throughout all of this. So it should be pretty fun. But I encourage you to, you know, take some time to kind of maybe just run over some of the things that we've touched on that you may not be great on. It's okay. You don't need to be, or you do not need to be amazing at all the stuff once we get there, but just to kind of get you prepared as we're kind of running through. I highly advise you to kind of touch back on some of the things that we've been going over, because I think it'll be pretty fun as we get there. But let's open this back up real quick and see if we can fix it. Oh yeah, it's just the return on the var3. Yep, that should do it. Okay, but then I get var2 is not defined. I tried to return var2 here. That's interesting, actually. So actually, let me think about what's happening. var1's here. var2 gets created here. I return it out of some func. So I have to capture it. out of some func, I guess. I have to capture the value. The value gets returned. The variable does not get returned. The value gets returned. So that makes sense. That actually makes a lot of sense. This wouldn't work. Like var2 is not even though I'm setting it here, return does not set this variable globally now. It's only going to return the value. So it's actually returning 6. So it's basically like it's returning, when I run that return, it's returning the value of 6, which I'm not catching anywhere. And it's only going to return it actually for some func. So if I caught the value of this, if I was like x equals some func, I'll delete these, and I printed out X. That's gonna give me, I might not run, but yeah, it's gonna give me the value 6. Called it because I'm so smart, and I'm just, I'm sometimes I think I'm a genius. When I actually look at something, I can break it down, and I know everything in the world. And I just said it was gonna be 6, and I ran in, it was 6, and you should be proud of me. That's what I'm saying. You should be proud that I got 6. But no, you said 6 in your head before me. Okay, all right, maybe we're in tune, Sean. Maybe we a little bit of telepathy. Thank you for sending that answer over. But yes, that's why I see, but like things pop into my head, I had to try it out. But yes, you can return that data, but you just have to capture it in some way, and that doesn't set the variable, that simply sets the value. So stuff you learn. If you have no idea what we're talking about right now, that's good, actually. Like, that's, now that means we're not giving you bad habits for doing the things that we just did. But dive into scope, dive into functions a little bit, play around. But starting next class, we'll be solving problems, and we'll be solving problems from here on out, and it'll be fun, and it'll give you a way. Basically, we're timing it up perfectly with 100 days of code, because we'll hop on the exorcism.io, so you can check that out now if you want, whatever. And as you go into 100 days of code, if you're not sure what to do, some of it can be trying to solve some of those problems and going through some of those things as well. I think there's some great algorithmic problems on there, and there's feedback, and there's a community on there, which is super duper nice. Yes, Sean, that makes you a super duper genius. It makes both of us super duper geniuses, and no one can really tell us otherwise, because we've affirmed it. If there's one other person in the world who believes what you believe, you're right. That's, we shouldn't be spreading that misinformation, but that's how I feel right now. Barely Failed Solutions Architect Associate, going back and diving into sysops. Hey, first off, congratulations for getting close. Like I said, I worked in the industry for a long time, and I failed Solutions Architect Associate first time I took it, and I was a little bit hurt, to be honest, because I passed the developer with flying colors, and I barely failed the Solutions Architect Associate. No biggie, you will pass it when you go back. I believe in you. Sysops, yeah, dive into Sysops. Sysops is harder. I was surprised at how much harder it was, to be honest, but yeah, Sysops is harder, but 100% you'll pass. Congratulations in advance already. Also, congratulations to just taking it on as an undertaking. It's a fairly highly sought after certification, so it's cool. Python, are we gonna learn Poto 3? If you meant Boto 3, no, we aren't. I don't know what Poto 3 is, but I assume you meant Boto 3, since you were just talking about AWS stuff. We will do some Boto. Yes, actually, we won't learn Boto 3. We will do some Boto 3 stuff when we get to the serverless section of that one. Yes, so we're going to be doing some stuff with Lambda. We will be doing some Boto 3 stuff. What's that song called? The one that goes bleep bleep bloop bloopy. Yeah, the bleep bleep bloop song. Yeah. Yep. Cool. All right, I'm giving you your time back. I'm also taking this time so I can get the stuff out that I need to get out for you all. So keep an eye out for that. People who need to catch up on videos, those videos are going up tonight. I'm gonna try to get all caught up tonight with this extra half an hour. So I appreciate your time, appreciate your energy. Hopefully you're excited about starting to learn how to do some problem solving starting on Thursday. If you are in Horizons, what are we doing tomorrow in Horizons? I have no idea what we're doing tomorrow. Nope, not there. I can tell you in 1 second because I'm not logged in here. Tomorrow in Horizons, we are doing some on-prem services stuff, all about databases. We're gonna be learning about RDS as well. So if you're unfamiliar with databases, relational databases, we will be diving in with that tomorrow. We won't really talk that much about on-prem services because it's a pretty boring concept. There's not really much we can do with it, but there is some stuff that you need to know for the Certified Cloud Practitioner exam for that on-prem service stuff. Excuse me. So we'll be diving into that. And the next week is a Beanstalk lab. I hate Beanstalk, but we will do that. But let's head over. If it's on YouTube and mod, yeah, I mean, all of it is on YouTube. There's playlists on YouTube. They're all there. Everything except for like I'm all caught up except for last week. So I'm just trying to get that there. It's already there. Who we rating? Who we rating tonight? Let's see. We've been going small. Let's see who's on. Do we have any friends on? let's see, Twitch. I'm not even logged into Twitch here. Prime's on. We gotta get Prime over the 200 mark. So we have to go through. We didn't do Prime last night. We're gonna do Prime tonight. We're gonna say what's up. Yeah. I did get the job Bonzo practice exams for the time. Oh yeah, that's dope. That's dope. I also, so for anyone who's in Horizons, I need to get it to you. I do have a discount code for Wiz Labs. I will share it. I'll definitely get it. I'm bad at stuff like this, but I'll get it. Oh, but absolutely. So we're gonna go head over and say hello to Prime. I need to do it from this computer because I don't know what I'm doing. So let's get ready to say hi. Let's get him over 200. The Prime again. I spell it wrong the first time every time, and I got it right the first time this time. That means today's a great day. I'm happy. I'm really proud of myself for doing that. So let's get over there. Let's say hello, learn a little bit about him. He's been doing some cool Dino stuff, which is a node. It's basically like node written in Rust. But check it out. Say what's up. Everyone have a good night. I'll see you tomorrow.